So mod 2.2 is basically about representing quantities and change in quantities. These are concepts you would have done in algebra course that you've had before, except I think the main difference is that there's going to be a lot more words wrapped around it initially, and that's kind of the biggest difference. So let's take a look at example 1. We're going to do these together, and then you'll turn it in when you're done. So number 1 says, at the beginning of the year 1900, the US population was about 76,300,000, and Canada's population was about 5,500,000. We're going to let U represent the US population some number of years since the beginning of 1900, and we're going to let C represent the Canadian population the same number of years since the beginning of 1900. Based on this context, consider each of the following expressions. What quantities value is represented in each case? So remember, it's sometimes what I will do is I'll make myself a little note to the side. What did they say those quantities were? Okay, so you remember is the US population some number of years after 1900, and C is the US or the Canadian population so many years after 1900. Okay, so what would U plus C represent? The total population of those two countries some number of years after 1900. So we'll just put a little total population. So it's the total population, however many years they have let go by after 1900. That would be the total population of US and Canada. What would U minus C end up representing? The difference between them. And I think, thinking about subtraction, there's a lot of words that you can use for subtraction, but I think difference is a good way to think of that. So this is the difference between the US and Canadian population so many years after 1900. Now let's try to put into words what we think U divided by C would represent. What do you think U divided by C would represent? Anybody have an idea? How many times larger? Yeah. Division, remember, is the opposite of multiplication. So sometimes you'll get that times notation in there. So this would be how many times larger? How many times does it go in there? The US population is versus the Canadian population. What about C or D, which is C minus 5,500,000? So think about where that number came up, that 5,500,000. And so what would C minus that significant number they mentioned earlier, what would that represent? What do you think? Yes, what you think? Yeah, so we could say, or you could say the change since 1900 or the difference since 1900. We don't necessarily know in our minds. We think it's going to probably go up, but you don't know unless you know exactly how many years they talk about. So I would use the words change in or difference in. So the change in the Canada's population since 1900. Again, you could say the difference between now and 1900. I would say if you said increase, it's fine. But again, we can't necessarily know that, but odds are there was an increase. Okay. So that's just a little bit about how we can take words from the problems, assign variables to those words, and then how the different mathematical expressions mean different things, okay? Any questions about problem number 1? Okay, let's take a look at a kind of a new phrase you're going to hear quite a bit in terms of. And if you see that mathematically, if it says write the expression in terms of, it's to write an expression to represent values of one quantity based upon another. We saw this when we did mod 2.1, when we were dealing with the distance that Desiree had run, and we had said how much more does she have before she hits the finish line, and write that in terms of the starting distance. And remember how we got that 26.2 minus D. We've actually written X in terms of D. So if I would want, many times you're going to hear, write that in terms of X. That's the most common. Write that in terms of Y sometimes, but many times you're going to hear, write that expression in terms of X. Okay, so that's what that in terms of means. We want that expression to contain that variable. So let's practice kind of doing that very thing. So it says in number 2, given the following variable definitions, complete the task in this exercise. X is the side of a square. So let's just put a little X here. So a square has the properties that are all 4 sides are the same length, and we've got right angles in those corners. P is going to be the perimeter. So we know we should add up those 4 things in order to find that perimeter. We could even say that P equals 4x. And it says the area, we're going to call that A, is the square's area in square inches, and the area is going to be x squared. So hopefully those are just formulas you recall from geometry, or along the way you usually use those formulas. So A says write an expression. Now it doesn't say to write an equation, it says to write an expression, so you don't need it equal to. If you used one, that's okay. It says to represent the square's perimeter length in terms of its side. So all they want is the 4x. The perimeter is 4 x's. And so x is what we used to do the side length. And what's great about having a representation like that is when we get to B, where it says what is the square's perimeter length when its sides are 5.9 inches, is we can just do a substitution. Please make sure to keep the units if there are units involved. And so 4 times 5.9 is a total of 23.6 inches. C says write an expression that represents the square's side length in terms of its perimeter. So this, we are going backwards from what the formula was that we have up here. If we want to know the side length and we had the perimeter, can anybody tell me what expression we would use to find the side length if we knew the perimeter? Yes. Yes. Well, not 1/4 x. No. It's 1/4 of what? 1/4 of what thing would we find the side length x? 1/4 of the perimeter. So you had it all. You can write it 2 different ways. I would be okay if you wrote it 1/4 of P. So that's what I think you were thinking. Or we could put P divided by 4. Both of those things are perfectly acceptable. So if we took the perimeter and took 1/4 of it, or the perimeter divided by 4, we would find the side length. You could also, if you wanted an equation, that would be x equals P over 4. And then D, I thought was kind of interesting. It says, what is the side length in terms of the area? So if we knew the area was a certain amount, How could we go backwards there and find the side length? Yes. Square rooted. So we would have to square root the area. Now, be careful. In many times when mathematically we take a square root, you have to put a plus or minus. But since we are going backwards to a length, we're going to assume that is a positive value. And that's why we don't need that plus or minus. But many times, remember, square rooted something, you might have to put that plus or minus symbol on there. So I like to remind you of that. And then E says, write an expression that represents the square's area in terms of perimeter. So what's the formula we normally associate with the area of a square? Length times width, side times side. In this case, x times x, right? So we would normally say that the area is x squared. But we want to write it in terms of the perimeter. How do we know that the side length can be rewritten in terms of perimeter? We did it earlier. How was the side length rewritten in terms of perimeter? We had done it in one of the earlier problems. Yes. P over 4. So we can just do the P over 4 squared. So what it does is it gives us a new way to represent the area in terms of the perimeter. So the only variable we want to see when it says in terms of perimeter, we only want to see the P in that problem. And you'll notice that's exactly what we did. We got that P over 4. So what's great is F then, we have now a formula. We know that the area is P over 4 squared. So if you know the perimeter, 42.8, we can just stick that into that. So it will be 42.8 divided by 4 squared will be our area. 42.8 divided by 4 is 10.7. And if we square that, we get 114.49. And what would our units be for this particular one? What would our units be? Inches squared, that's right. So make sure that you account for the fact the side length and the perimeter are both just inches in this case. Area would be square inches, okay? So that leads us now to G. It says, write an expression to represent a rectangular's width in terms of its perimeter length and the rectangle's length. We're going to define some variables to stand for those things. When they say a rectangle, the first thing I do is I draw a crude little rectangle on the side of my paper. It's always a good placeholder for my information. I'm going to call W the width in inches. I'm going to call L the length. Gosh, I can't wait. In inches. And so the perimeter is if we have two W's and two L's to create that rectangle. And what they want is they want us to find the width in terms of the other two variables. So they want us to just solve for W and move the other things around. So let's just take this, subtract off two L's, and then we have 2W by itself, but how could we find out what plain old 1W would equal? How would we get rid of that 2? We just got to divide. And so we would get that the width is perimeter minus 2L divided by 2. Now, feel free to divide by 2 if you want, but P would have to be still written over the 2. The L would, just be 1L, but that is a good place to start for or to stop for those things, okay? Any questions about those ones? Do we have any questions? Okay. We are going to have to remember how to graph on the coordinate plane. Remember that we are looking for where a point is. The independent variable will be our x's. The dependent variable will be our y's. So our x's go from left to right. Remember, this is positive and this is negative. Our y's, our dependent variables, are going to go up and down. Remember, this is up is positive, down is negative. Remember, the origin is our point 0, 0. So if you see that terminology, origin is just our center value at 0, 0, where the x and y axis intersect. So those things should be very familiar to you. So the 0.43, 4 would be our x, would be our independent variable. 3 would be our y, which we would consider our dependent variable. The way that I remember it, it's a silly way to remember that, is the y that we get depends upon which x we decide to choose. So, because most of the time you're going to start with a certain x value, and then your y value will depend upon that x, if that helps you remember the difference between those two terminologies, okay? So let's take a look at example 4. It says Hector and Brandon are 45 feet apart and start walking toward one another at the same time. Hector is walking twice as fast as Brandon. So when Brandon travels some number of feet, Hector travels 2 times as far. The 2 men stop when they reach each other. Write a formula that expresses the distance between Hector and Brandon in terms of the number of feet Brandon has walked. Define any variables you use. So do you see how it says in terms of the number of feet that Brandon walked? So that's the variable we really, really need. So we know x is going to be the number of feet that Brandon walks. Now, if we read it, it says that Hector travels 2 times as far. So in terms of x, what would Hector's distance be? 2x. So let's write 2x as the number of feet that Hector walks. Okay. And then let's call y the how far apart they are. How far apart Hector and Brandon are. So let's think about something for a minute. They start out and they are 45 feet apart. They're walking at a certain spot, they stop. Brandon has gone X number of feet. Hector has gone 2X number of feet. So the distance now that's left is 45, take off whatever they have walked. Now, what could we do to make X plus 2X nicer? Combine them like terms. That's going to be 3X. So I would say that we would get Y equals 45 minus 3X. So let's label, part B says to label the axes on the given coordinate plane based upon the conventions described in the definition box. So based on that independent and dependent variables, our X is going to be the feet that Brandon walks. Our Y is going to be how far apart they are at any particular value. Now, part C says to plot the points. Now, please, anytime you are provided with graph paper, whether it's from me or whether it's one of these lessons, whether it's on iMath, whatever, always check to see how have they broken up their X and Y. If they don't label it, that you can assume that it's by ones. But how are they counting on the x-axis? By what? 5. How are they counting on the y's? 5. So always watch that. Always account for that before you start jumping in and putting a point down on your paper. So the first point they want us to label is 0.45, which is up here. Then 10.15. Then 15.0. Says, what do each of these points represent in this context? So let's go with the point 10.15. So when Brandon has walked 10 feet, he is 15 feet from Hector. Now, why is that? Well, if Brandon has walked 10 feet, Hector's walked 20, 10 plus 20 is the 30, they still have 15 to go. So the point 10.15, when Brandon has walked 10 feet, he is 15 feet from Hector. Because our x is how many feet Brandon has walked, our y is how far apart they are. Part D says to draw a line through the points you have connected. Let's do that. What do the points make up that make up this line represent? At any particular x, we can find out how far apart they still are. That's what it represents. It's the relationship between x and y. So for every x, we can find the y or how far apart they are. So that's what the graph is helpful for. So let's say we know that Hector's gone 5 feet. They still are 30 feet apart. Maybe we know that Hector has gone 7 feet. They still look like they have, they're 27 feet apart. So it just allows us to find for every x how far apart they are at any particular time, okay? Do we have any questions about that? Does that make sense? Kind of maybe a little bit. Okay. So now there's some notation that you probably did in an algebra class. It depends on how your algebra teacher kind of discussed slope and some other things. We are going to use, especially as we're head toward calculus, we're going to use the delta notation to depict a change in a value. It should be your x2 is your end, your x1 should be your start. So please note that your x2 would be your end and your x1 would be your start. That delta notation, that's just the Greek letter delta. If you ever see that like on a sorority or a fraternity, that delta triangle just is the Greek letter delta. We use Greek letters a lot to denote different things in mathematics. And it's just delta x is x2 minus x1. Delta y would be y2 minus y1 and so on. So in this example, it says if x changes from 6 to 19, delta x is 19 minus 6, because this is our ending and this is our beginning. If you end up with a delta x that is negative, you know you've gone down. So if our start was 19 and our end was 6, then you would get a negative 13 value. So it is important to always do end minus start, or you're going to get the wrong sign along the way, okay? Everybody good there? So the last page we're going to do is just kind of talking about those change in values, okay? And then you'll have some time to work on your iMath. Okay, so last page we're going to do, number 6, says, the given graph represents the depth of water in a reservoir in feet, in terms of the number of months since January 1st, 1990. Define variables to represent the values of the quantities in a situation that can vary. Okay, so let's take a look. always look, how did they label your X and Y axis? That's telling you what your variables are. So we're going to let the X be the number of months since January of 1990. We're going to let Y, if we look at our Y-axis, be the depth of the water of the reservoir in feet. So we're going to be depth of the water in feet. Okay, so it says interpret the meaning of the point 468. So 4 months after January 1st, 1990, the depth of the water is 68 feet. So your labels of your X and Y axis should give you all the information that you know. So do not make these more difficult than they are. Use your graph that has been provided and the information that's been provided, okay? Remember, your X should be your independent variable. Usually something, time is a very common X. And then the depth of the water is changing in terms of the time of the year or whatever the case may be. Okay. And then for C, it says, label the point 620 on the plane. What does this point represent? So again, always check, how did they number their points? How did they count on the x-axis? How did they count on the x-axis? It's kind of just by ones, right? It's just 1, 2, 3, 4 months, okay? So if it helps you to put months, you could. And then this is feet, right? But let's take a look. 10, 20, 30, 40, 50, 60, they're counted by tens. So always note that before you get started. So if you wanted to label the point 620, that is the point right here. And that it is 6 months after depth 20 feet. Now that is not a point on our graph, so that is not an accurate information based upon what's there, but based upon if we wanted the point, if the 620 was there, that's what that would represent. Any questions about 6A, B, or C at this point? Does anyone have any questions? Okay. Now, let's go to D. It says use the graph to estimate the number of months since January 1st, 1990, when the depth of the water is 45 feet. So what I would suggest doing, find 45 and I kind of think we have 3 times that that's happened. Can somebody tell me one of the values where we see that one of the months? So I see 6 months, yes. 1 month and one more. 10 months. Okay. So because that was the dependent variable, you are allowed to have more than one answer. X's in a function, if this was a function, X's are only paired up once, but Y values can occur multiple times because if that graph does any sort of like a little wave and comes up and down, okay? Now, E says, the number of months since January 1st, 1990 increases from 1 to 3. What is the change in the number of months on this interval? Use the delta notation. So if we say that's an X, that would be a delta X. X1 is 1, X2 is 3. You got to do 3 minus 1, and so it's 2 months. So it's 2 months. So delta X is it changed in 2 months. Represent the change in part 1 on your graph. So really, we don't know much. We are just looking at the change from there to there. And on our graph, why don't we even label those points up top? So 1 to 3, I'm so sorry. Let's focus in on the number 2. 1 to 3, and then let's just dot those points out. Okay. Now, it says, what is the change in the depth of the water from month 1 to month 3? So this would be a change in our Y value. Do you want to just go, I'd say 45 and 70? They hit pretty darn close to 45 and 70, because this looks like it's the 0.145 and this looks like the 0.370. We'll approximate, make our numbers a little easier. So 145 and 370. We are only looking at the changes in the Y's. This would be Y1 and this would be Y2. You'll see that that part of the graph, the change of the Y went up. So it would be 70 minus 45, or 25 feet change, an increase in 25 feet. So if you end up with a delta being positive, that is a increase. We have gone up. If it's negative, you want to think of we have gone down. And it says represent part 3 on the graph. So part 3 on the graph, we really are changing the Y. So the X value changed from here to here. The Y value changed from here to there. We could do it like that. We could put the X value, this would be delta X. This would be delta Y. Okay. So that is mod 2.2. Please turn this in to get yourself some points. And then go ahead and open up your iMath. Take a look, keep checking that grade book, because that will tell you the dates and it will also tell your score. So keep checking that grade book as you go to see when things are due. Remember, you don't have to turn in necessarily anything in Google Classroom. I will do that for you and transfer the grades from iMath. So everybody work on that, and then if you have questions as you go, let me know.